Afternoon to one and all present here. Today, on behalf of Robotics and Automation Engineering, Mechatronics Engineering, Biomedical Engineering, and EC and IC Engineering, I, Dr. Haley Shah, welcome Dr. Vishwajit Thakur, Principal, Noble Engineering College, to give an expert talk and webinar on robotics, the innovative applications. Sir has completed his PhD from IIT Mumbai, Systems and Controls Interdisciplinary Group, and Sir is presently working as a principal in Noble Engineering College, Noble Group of Institutes, Junagadh. Sir has worked in the area of robotics and mechatronics since last many years. So before wasting any further time, let us hear from Sir. Sir, over to you.
Okay, thank you very much. Thank you very much for the nice introduction. I will be presenting my webinar and topic on robotics innovative applications. As robotics is not a new branch, it is actually since long existing, maybe 1990s, and a lot of industrial robots were there in practice. So what pictures you are observing in the front slides are different kind of robots, and these robots are basically known as robotic arm. Then a gradual development in the robotics has taken place, and today we are able to see up to a humanoid robots. So you can see that robots are used in large number of applications. There are a lot of confusion about robotics, that whether it is mechanical, whether it is electrical, whether it is a computer. So it is basically a specific branch which requires a knowledge of electrical, electronics, computer, embedded systems, mechanical, hydraulics, pneumatics, and stuff like that. So it is interdisciplinary in nature, but at the same time, it will have applications in different fields like civil, agriculture, space, medical, and stuff like that. So you will have huge applications of robotics. So what innovative applications we are going to see today are many. So I have organized my presentation with some of the videos as well. These videos I acknowledge the IEEE video clip contest, and those videos you will be able to see today. If everything is fine, if bandwidth is okay, so you'll be able to see the videos very well. As I have told you, it is an emerging branch with large number of applications in different fields. Earlier, it was a popular robotic arm widely used in industries for pick and place applications. In fact, before robotics came, there was a CNC machine. Computer numerically controlled machine tools were there, and then there was a robot along with them. Each one performed a different task. Robot arm has to actually move in its workspace. It has to sense, it has to control, it has to take decisions, and it has to provide a safe environment. So in this particular seminar, we are going to talk about different robots and different applications, and you will find something new which you can try in your laboratory. This is what we usually do, that we try to make the robots with fun robots. Like for example, there is a Lego kits, and with the Lego kits you can make different kind of robots. All right, those are all fun robots, as we say. But actual industrial robots require huge power. The basic problem with a small mobile robots are battery and power. You cannot connect cable everywhere at every point of time. So you will have to have a mobile battery which runs longer time. So as a part of that, energy harvesting in a various networks and sensor networks are being used so that battery can be charged and recharged. At some of the places, solar panels are mounted on the robotic applications where power comes from the solar and battery both. So this is something new where everybody is running behind the energy. So in robot, it requires a huge energy, and huge mechanism are used in robots. Defining the robots. It is very difficult to define a robot as well as it is simple. We say robotics, anything which runs automatically is a robot. But when you have to give a program, okay, so it is a reprogrammable. You can program it again and again. Multifunctional, that means it can do a lot of tasks. For example, it can do assembly job, it can do spray painting job, it can do arc welding job, and so on. It is a manipulator designed to move materials, parts, tools, or specialized devices through variable programmed motions for the performance of variety of tasks. What was done in earlier days, that entire robotic arm has to move in a workspace, and the definition of the entire workspace, the definition of the entire workspace has to be captured in a memory of a computer, and this robot will use a memory of that particular computer to re-perform the task which it has recorded. So typically saying that for any robotic arm or for any robotic application, you need to define its boundary. Okay, that's why, at many places you have seen line following robots are used. So what is the meaning of line following robots? That you are creating a boundary. Similarly, you can create a boundary when there is a aerial vehicle or a drone or a farm. So when you have this kind of activities to be done by robot, a boundary making is very, very important. For example, when a robot is used in a warehouse, okay, when we say warehouse, means it's a huge place where storage of material is being done. So warehouse robotics required a typical boundary areas to be scanned and recorded, and then only the automated guided vehicle will move around. So as a definition, automated guided vehicle is also a robot. Okay, so automated guided vehicle is a one kind of robot, and in robot you have a computer vision. You have a computer vision typically nowadays. That is a vision camera. So earlier there was a force sensing, a kind of grips and force sensings were there in a systems. But nowadays, since low cost and micro cameras are available, low cost and micro cameras are available, we are able to use a vision camera for guidance and also even for capturing the boundaries and throwing out the objects if it is not in a workspace. So defining a robot again, a robot is a reprogrammable, multifunctional manipulator. Okay, that's a manipulator arm designed to move materials, parts, tools, or specialized devices through variable program motion for the performance of a variety of tasks. This is what a robot in general was defined. But in today's scenario, the robots are totally different. It is now not only a manipulator, but it's a flying object. But still, yes, even in medical robotics, for example, you have to do a spine, you need to have a augmented reality probably, and then you have to take a particular arm to a particular place in a body to do a surgery. That is a medical surgery. In a medical surgery, medical robots are used, which definitions may little vary. What this definition implies is for industrial robotics. So in industrial robots, you are able to move the materials and parts. For example, you consider a large gear manufacturing company. So when you have a large gear manufacturing company, then you have to move one gear from other place, from drilling machine to say milling machine to say grinding machine. So when you try to move it from one place to another place, you need a robot, and that's why a robot manipulator arms were used. If you are trying to move any object, parcels for in a warehouse, say for Amazon, you have a huge warehouse of material that you are ordering. So for placing and picking those different kinds of robots, items, coordination among the robots are done. So there may be a network of robots which are be working. So this definition of the robots is changing as the period is changing. I'm trying to show you one simple applications through this video. So try to see this application. So then we'll proceed further. It will give you a good idea how Lego robotics can be used.
Sir, video is not playing.
Hello.
Yeah, hello.
Yes, video is not playing, right?
Yeah, it is.
Because wait a minute, I'll have to share my entire screen to you for that.
Yeah,
All right. So I will try to do that for a while. Okay.
yeah.
Thank you. I'm stop sharing. I'm going for uh, different my entire screen sharing, so you'll be able to see everything. So you will be able to see my screen now. All right. And then if I go for my presentation, you will be able to see that. Wait a minute. Okay, so you will be able to see that. Let me know if you are not able to see.
Yes, sir, it is visible.
Okay.
Option, course, sessions, and previous. Fine. So now I have shared my screen. I think that will be visible to you. Okay. So you can see that when you click on the course, you have a two option. One is the import course, another is the add course. So for new course, we have to click on the add course. Okay. You all have to do these parallel activity with me. Fine. जिनका लॉगिन चालू है वो सारे फैकल्टी को ये एक्टिविटी पैरेलली मेरे साथ करनी है. Right. So click on the add course. So it allows you to enter the
Any ma'am?
ulms.paruluniversity.ac.in ते इथं थटू नाही. थंय बापा. हाँ सर.
So I think you can see this. Now, this was an interesting videos that we had seen, and you can see a lot of things were funny also and interesting for the students to build upon. So student can easily build this kind of robots at their own. So college students jointly with the school students can buy small kits, and nowadays Arduino, Raspberry Pis are easily available, and wireless technology modules are also very easily available. So we can make a different kind of robots, and a complete robotic activity lab can be set up, and students and the faculty with the different university, different colleges, schools can come together to build a robotic applications. Going back to the industrial robots, as you know, the Puma was one of the oldest robot designed by Unimate. This is what the structure of the robot look like. You can see that these are the older versions, and this is where mathematics, kinematics, dynamics, Cartesian coordinates, cylindrical coordinates comes into the picture of mathematics. So when we study coordinate system maths, question comes to us: what is this? Why are we studying? Now you can see easily the different kind of joints, 1, 2, and 3 different, and 6 degree of freedom robots you have. So these are the industrial robots. This can be a arc welding robot. This can be a spray painting robot. This can be a vision camera as an AND factor. Likewise, okay. So this is the typical pictures of industrial robots that you can see. When you see the industrial robots, they are here and there, okay, in different applications. You can say it's look like a typical camel. This structure is a camel-like structure if you look at it. A different type of, but they are all heavy, and there is a motors, high level DC servo motors, AC servo motors, stepper motors, BLDC motors. As the advances in the electrical machines are ongoing, the joint motors also keeps on changing. So these industrial robots, I have shown a picture just to have an idea to the students that robot will look like this. And this is the graphical pictures, and these are the photographs of some of the industrial robots. The history of the robotics that starts back 1978, programmable universal machine for assembly by Unimation. This is typically the Puma robots, you can say assembly robots, okay. When you have a large number of parts to be collected together and put together in a day, then you require the robot which works very, very faster. So these are the older version, 6 degree of freedom version, when you have a 3 degree of freedom at the end effector and 3 degree of freedom at the joints. So 6 degree. You can see these are the different links here: link 0, link 1, link 2, link 3, link 4, link 5, and link 6. You have different kind of links over here. So what you have is to control each and every link, you need a controller. So these every joints which are shown here, here, these joints are basically connected together, and these joints are called a servo joint, and they have a tacho generator encoders mounted at the shaft which continuously give feedback to the controller. These are the base of the robot. So this pictures gives you an idea of how the robots will look like and still look like in some industries. This is a SCARA robot introduced early by a technology in the US. You can see a different kind of structure totally than what you had seen previously. This is known as a hose pipe, okay, through which various wires and connectivity goes, maybe hydraulics, maybe pneumatic, maybe electrical. This gives you a much better idea about different joint 1, 2, and 3 joints and end effectors, joint 4. This is the base. So this rotates, this rotates, this rotates. And whenever this rotates around a particular space, it is known as a robotic workspace. It is known as a robotic workspace, So you can see that different kind of SCARA robots in this picture, which is picking up. You can see this is end effector, okay. Remember, this is an end effector, and this is your cylinder, okay. End effector and a cylinder, okay, in which tool is mounted. So tool is mounted in this particular cylinder. All right. So these pictures are showing you how robots would look like. People have an idea that it is like exactly like a humans, but not like that. It's basically a machine, kind of machine. And this is a different kind of, this is typically the manipulator arm, we can say, in a particular case. I will show you another video. We'll see a ball balancing robot. If it doesn't, so please let me know. Gradually sound will come.
Sir, audio is not coming.
Okay, because audio is here in my PC, but that's fine. You can just see it is just a fun kind of music, nothing there. There nobody is speaking anything. This is just a visual. This is just a visual kind of things, and the background music is there.
Sure, sir. Sure. Thank you, sir.
It has to just observe what is happening there. Yeah, so that was a balancing robot. There was no actually voice in that. We have to observe the sensors, controllers, and how nicely it works. So you can see ball balancing is a typical problem which is used in a control theory. The ball beam problem, then beam tries to control the movement of the ball. And here the robotic arm is used, and you can see there is heavy mechanism, heavy friction is involved. So as the development is done, then in different kind of manufacturing systems, this also keeps on updating themselves. And magnetic levitation systems can be much useful for balancing such board. So there can be a project one can write, that magnetic levitation based ball balancing problem for a robot. This is something new. As you know, we have a Cartesian coordinate robots from their axis. We have a cylindrical robots. We have a polar or spherical robots. Application wise, aerial robots, space robots, medical robots, agriculture robots, biologically inspired robots, cooperative robots, and humanoid. These are some of the areas where robots are used. This is the introductory part. The picture you see now, this is a huge robot, very heavy robots. Second is cooperative robot, which I have mentioned here. These two robots are working in a cooperation to lift an object and keep it in a stable position. For example, if you have to paint something on a road, you can put the robot on both the sides of the road, and painting can be done by both of them in a very systematic manner and a cooperative manner. This is most interesting to learn that both the feedback devices should communicate with each other, and it's a kind of a short network between the two robots which they work. The most important thing is these are simple grippers which are used. And when you see here in the humanoids, you have actually a human hand. So these are called robotic grippers, okay? Not the hand, but this is called robotic hand here. So both has a different structure. And when you talk about the hand for holding the object, the most difficult design is that of a fingers. Your fingers movements are there, and each finger movement should have a motor, and the smallest motor is required, smallest resolution is required of steps and feedback. So this first three I have written based on their coordinate system they are using, but sometimes when you use this kind, every joint has to have a coordinate systems, and it has to be defined like that. Aerial robotics are basically drones, space robotics are Mars rover vehicle, medical robotics, as I have told you, for spine surgery. Agriculture robotics are for harvesting the crops or irrigations. We'll see some videos of the biological inspired robots today, and a humanoid. So friends, robotics is an interesting area where you can work, and you can find out the different kind of applications, but what basically you need to have for each kind of robot, I will describe in a couple of slides. That robot is not difficult, number one. Robot is not easy as well, but you need to know the knowledge of everything and put them together is a robotics. So robotic branch has a lot of challenge to attract the different people with having a different interest. So this is what you will be observing in a robots in a different kind. And since 1990s till date, it has progressed like anything. And now with the various government rules, regulations, exchanges, and information technology has made it possible to robots to grow and to make it to every home, every people, and everybody is interested in robots. But defining the robot, designing the robot, applying the robot takes time. It's not an easy job. It's not like a simple computer program. Okay, it's not just a simple. It is something more. You need electromechanical interfacing, you need computing interfacing, and you need the sensor interfacing. Three different levels of interfacing are required in robots, and therefore you need to have a knowledge of electrical interfacing, hydraulic interfacing, pneumatic interfacing, depending upon how much power you require. How much power you require, that is important design for the actuator. You may have a smallest stepper motor, smallest DC motor. You may have a large fluid tank for oil tank, a large pneumatic pump. You get my point? That makes the size of an object. But as there is an advancement in micro electromechanical system, nano electromechanical systems, small robots are becoming available like platoons. Okay, you can say platoons of vehicles are thrown in a desert for a defense applications. So there are huge applications. All of you must have seen a Doom movie, and in that there was a robot which was a line follower, remotely controlled. But those are fun robots. So that's why you have to classify which kind of application you want to develop for a robot. Okay, so it's an application specific, and design will take appropriate part. So if you take cooperative robots, it's different. If you take agriculture robot, it has to run in a sand. It has to run in an odd even land. If it's a more medical robot, it has to deal with a body, human body. So it's very delicate things, and it cannot be done anything randomly like industrial robots. So everything has to be very precise, very accurate, very sensitive, very safe. That's why people are worried about use of robots. Robots are not going to replace humans everywhere, but you will require humans to prepare robots and train the robots. Friends, in the recent time, artificial intelligence and machine learning has made it possible for robots to become intelligent. Okay. But what is AI and machine learning for robots? It is basically a control algorithm that runs. It is basically the control sensing and intelligent sensing that is done. It is basically the intelligent decision making that is done. So artificial intelligence and machine learnings are basically used in the algorithm form to take the decision for actions. All right, let us see one more video of humanoid robots from Honda Robotics. So these are different positions of robots. You can see these are interesting things. You can see the new function. Hospitality management. This is amazing, isn't it? So it's saying goodbye now. So friends, you have seen a humanoid for different tasks it is performing. So friends, it is not now, just a fiction or a cartoon movie. They are existing. And, friends, in many various countries, multinationals, companies are coming up. And they have trends that something new comes, they put it up to public as a demonstration. This is what we need to do at our place as well. Something we do it. Let us put it to the public to see, and let us get a feedback from them. I hope that with this video which you have seen, which was an ultimate robot, a humanoid, which was performing everything. It was taking voice commands, right? It was wireless communication. It was fully automated. It was doing everything that a human can do, but at a different speed, different command. Still, you can say what is missing. According to me, the flexibility that we human has is still missing. It is not as flexible as a human. What from where skin, flesh, body, blood, things, biology that we have is yet to come. You will have a structure. So what we say is the robot will be available. They are available with the structures of different kind that exist in nature. But exact human is, they are trying a lot. Industries are trying, people are trying, but they are able to get the structures, not the feel. They're trying to get the feeling as well. Emotional sensing, drowsiness sensing, whether you are laughing, you are crying, you are shouting, everything is happening in robots. Okay. So last video that you have seen was amazing and one of the best video that you can see. That was taken from IEEE Video Clip Contest. They have submitted, or from the promotion of the Honda. Now, for those who are new, I'll tell you what are the important parts of robot that if somebody asks you, you should know is. First important is arm link for industrial robot. Robot sensors, like you have tactile sensing, જે આપણી ચામડી હોય, કે ચામડી ઉપર જે લાગેલું હોય, એને tactile sense, touch sense કહેવાય. જે આપણા મોબાઈલમાં આપણે સેન્સ વાપરીએ છીએ, ટચ સેન્સ છે, એવા સેન્સર્સ હોય છે જે બોડી. સપોઝ હું તમને એક સિમ્પલ એક્ઝામ્પલ આપું. I will give you one simple example that you have to hold an egg in your hand. You have to hold an egg into your hand. How are you going to hold it? The force that you have to apply, the sense that you have to make with an egg is very important. How to give a control force, that is important. So that's why touch and tactile sensors, proximity sensors, ultrasonic sensor, range sensors, IR sensors, all these are available as a sensors, and these are sensors with nearby environment. Then robot actuators like motors, valves, compressors, like that. Robot hand effector, grippers, robot hand, a finger, like that. You have a robot computer, that is a controller. So you have a robot controller with you. Okay. Robot workspace, robot vision, and robot programming. Look at this slide very closely, what a robotics means. Okay. So when you go here, robot hand effector, complete mechanical design comes into the picture, pneumatic design comes into the picture, hydraulic design comes into the pictures. Robot actuators, electrical and mechanical actuators are coming into the picture, piezoelectric actuators are coming into the pictures. Robot sensors, electronic, mechanical sensors are coming into the pictures, complete mechanical design, complete electronic vision, camera, complete computer programming, so workspace, complete kinematics and dynamics. So you know these are the important parts of any robots. Okay, so with these robots, everybody must know that robot is not a miracle. Yes, it is a miracle, but not a miracle. It is consists of these things, whatever you have. But nowadays, important part is wireless connectivity. Okay, voice commands, speech processing, these natural language processing are additional parts of these particular robots. You know, insect-like robots are also available, and you can see that there is an insect-like robots. Okay, insect-like robot means an ant. You can see that a complete mechanical design, very small design, sensors, vision, camera, structure. So this is known as a biologically inspired robot. We go to the next slide. This is a biologically inspired robot, snake-like robots. We'll have around a 3-minute video. This is from NTNU. So, friends, we have seen that there were the same kind of snakes, same kind of biologically inspired robots. The two things you must have noticed, there was a wire. You always need a cable connectivity to power it, number one. Number two, all the design, all mechanical designs were different in different types of snake-like robots. So what challenge we have as a robotic engineer today is, number one, how can we design a robot which doesn't require, cables, so battery operated, and how long that battery would remain, so rechargeable. This is what the challenge that we have to learn. And what we have seen there, what you have seen there are different type of motions, so mechanics. So complete mechanical design, control force design was there. A pipe inspection robot are used in many applications, even today's, but it is not available to the public. So those who are in robotic engineering would definitely understand the applications of the piping robots, pipe-like inspection robots. I'll just show you another insect-like robot quickly, a flying robot. Acknowledgement Festo and Dr. Neeraj Shah. So this was flying kind of robots. I'll show one more slide on video on butterfly. Just see that, it's interesting. Once again from Festo. Just 1 minute. So this was there. So I think it was an interesting thing to show. Now I'll go for one more simple applications, a bottling plant, robotics applications for a bottling plant. What you need, because I visited one of the plant nearby Pune, and there a lot of scope I could found that in a plant, for example, the squash and the juice that you are fixing up, a different Semapro, for example. So development of bottle handling robots for food and beverage industries is a challenging problem. First of all, you have to make a robot that makes a bottle itself from the raw material. Number two, you need a robot which places the bottle at appropriate place. Number three, you need a coordinated system which feels the material, the squash or the juice in a bottle. then lift a bottle, and then collecting. So there is a scope of designing 1, 2, 3, 4, 5 coordinating robots for food and beverage industry. This is a challenging problem. And if you approach a company, probably you'll get a project from an industry. Those students who are in masters or BTech would have a chance to design a bottle making robot, bottle placing robot, feeding mechanism, lifting mechanism, and collecting mechanism. These are all guided mechanisms well known for dairy industries, but for food and beverage, there is still a lot of automation has to come. So this is a robotic bottling plant, complete automated robotic bottling plant can be designed, and students have a huge opportunity to work on each of the topic I am saying. Not every, each one has a potential of a one BTech project, one master's project, and even research in a PhD project. There is a robotic experiment here that you will see very interesting. And this is where how the robot is trained is shown. Please see this. You can see that it is how it is performing the experiment. This is what we need to do in our labs. So friends, you have seen that how experimentation are conducted even in lab for robotics, and person are doing experiment on themselves to get the data and design their own system. This is what the culture they have as a postdoctoral studies, PhD studies in various universities abroad. There is a spherical robot is there from IIT Madras. I will quickly go through because we are running short of time. Quickly, let us see this video. We don't have much time, much videos left now. This is from IIT Madras. It was also a video clip contest. You can see brushless motors with inertia disc. There is a battery. There is an optical encoder for disc speeds. Endoskeleton for orthogonal alignment. Processing electronics with bars. This is what the latest state of art in robots. Everything is inside. There is no extra cable. So, yeah, so Dr. Arun Mahendra was a colleague and he has made it at the moment. There are different applications: material handling, material transfer, machine loading and unloading, spot welding, continuous arc welding, spray coating, assembly and packaging inspections. There is other applications like solar panel cleaning for robot. So solar panel cleaning robots, sensing for dust, defining the boundary, vision-based guidance, control program is there, power driver and stepper motor. This is required for solar panel cleaning robot. You can have a vision camera to map the boundary. This is newest application is robotic digital postal ATM, which I have actually proposed a long back. And now if somebody can design it, it is a wonderful thing if you can do it. Automatic identification of address on the envelope needs to be done. Stamping needs to be done. Auto deduction of money needs to be done, and collection of envelopes. To have a robotic system work as a postal ATM and kiosk may be placed at the railway station or bus stations. There is a military and demining and surveillance applications, mining, excavation, explorations, transportation, healthcare, automobile, entertainment, utilities, warehouses, assistive mobile robots. For assistive mobile robots, you will have the on and off of a switch based on voice command for elderly people who cannot move and who have physically challenged people. So assistive mobile robots can be made even for a house. This is for those who want to make a block diagram of a system that how does AI robotics works. This is for them. Okay, that is a sensing environment. Electronic signal conditioning is must. Analog to digital conversion is must. They are on the same chip and controller with AI intelligence. So for block 1, 2, and 3, 1, 2, and 3, all the 3 blocks, 4. 4 are in the same chip is possible. This is separate, this is separate, this is separate. And when it goes for wireless like spherical robots, all through a power, all it needs require a power, and that power comes from the battery. So controller with artificial intelligence is a key, or intelligence of a system, maybe fuzzy based, neural based, deep learning based, whatever algorithm you put it there in a controller, which is possible, and which may be Arduino, Raspberry Pi, or large scale GPU or a quad core controller, depending on applications requirement. So please, this block diagram is a unique block diagram I made for those who want to understand what a robot is and how does AI get integrated and where the role of AI is there. So this is the role of the AI. Friends, innovative applications are AI-based robot for fetching items from Superstore, AI-based robot for fetching books from the library stack, AI-based robotic arm for water leakage detection, monitoring, and control. These are the innovative applications which one can easily make. The recent trends: Internet of Robots, unit web design, IoT protocols, physical and electronic interface, sensors, cloud, and ROS. So those who want to do a research project, BTech project, master's project, should focus on Internet of Robot and try to study robot operating system, which is specifically available. And now a lot of people are working on ROS for Internet of Robots or Internet of Robotic Things, you can say. So this is the ultimate application which I am putting before you to understand that yes, this is Internet of Robots. Okay. So there is a robot which can run, but we are running short of time. So actually I am acknowledging some of the images which I took from the internet. Engineer Neeraj Shah for Ariane Sati for some of the slides, IEEE Video Clip Design Contest, and some of the companies from where the videos are obtained. Thank you very much. If you have any question, you may please ask. I am stopping my slide sharing and screen sharing. Is that okay?
Yes, sir.
I am stopping. Yeah.
Sir, as of now, there are no questions coming.
Okay.
Because it was so informative and a nice session delivered by you.
Okay. Okay. So if you have any questions, we can proceed. Otherwise, let me know if
No,
anything.
sir. There are no questions.
Was it timely presentation?
Yes, sir.
Okay.
So thank you so much, sir,
Okay.
for such a wonderful presentation on behalf of Mechatronics and Robotics Engineering. I thank you for giving us insight in this subject.
Okay. Please do share your feedback with me about presentation. So
Yeah,
it will be useful to me.
sir.
Yeah. Do share the feedback.
Definitely, sir.
Yeah.
Yeah.
Thank you so much.
Okay. Thank you, sir.
So shall we leave, right? I'm
Yeah,
leaving the call. Thank you.
Yeah. Sir, Bridges, sir.